Okay, so the next part will be JavaScript syntax in 5 minutes. Because actually there are just some flashes about what you are expecting to find and what actually you will find, and then we come to some operation about on strings and arrays. But first of all, in this part there's nothing really new. We have a set of operators that are the same operators that you can find in mostly in any programming language. We have the assignments. You already saw that we can declare a variable and assign an initial value. So it's an assignment with a declaration with initialization, or a normal reassignment of a variable as long as it's not declared as const. And we have all the short forms of assignments like plus equal, x plus equal y means x equal to x plus y for all the basic operators. So these are like when I was saying the syntax is similar to C, this is what I meant. Comparison operators also are equal or different, equal or slash equal, exclamation equal. But we also have the strict equality like we saw before that prevents conversion. And then we have the normal greater or less than operators that we have, plus logical operators and or not with the same syntax as C, so double %, double bar, and all the normal arithmetic operators, plus, minus, multiplication, division, increment and decrement, both prefix and postfix, and exponentiation, division and exponentiation, which is not in all language. In this case, is a double asterisk. So nothing special here. We have a bunch of mathematical functions that are all properties of a global object which is called math with a capital M. So if you want to make a square root, it will be math.sqrt somewhere here in the bottom. And this is for most of the constants or functions, mathematical functions that we need. There are a couple of points to note. One is logical operators that are very often used also as a shortcut for control structures. For example, an AND operator, expression 1 and expression 2, we imagine that expression 1 and expression 2 should be Boolean values, okay? And so we apply the Boolean truth table to them. Actually, it's more powerful than this, because if you read the definition, say that it returns the first expression if it can be converted to false, if it's falsy, no, in the definition that we had before. Otherwise, it returns expression 2. So this means that it's a shortcut for if expression 1 is false, then false. Or maybe if expression 1 is undefined, then return undefined. Or if expression 1 is true, then return expression 2, whatever the type expression 2 has. So if it's a string, it will return a string. If it's an array, it will return an array. It will not convert expression 2 to Boolean. It will only check the Boolean value, to convert the Boolean value of expression 1. And the same goes for the OR operator. And of course, if expression 1 is true, return this, otherwise return expression 2. And this is useful. For example, let me, go back to the terminal. This, at the beginning, can be a bit strange, but if you have a variable that you don't know whether it's defined or not, you can easily apply a default value. No? Imagine that A is already defined, yes. Imagine you receive a variable called, I don't know, G. Yeah, let G. Sorry, go away. So G is an undefined variable. You maybe receive it as a parameter of a function, okay? You know that if you have a variable, you don't know whether it has a value or not. Maybe the user typed some text, or maybe the user didn't type some text. So you can do something like G equal to G or default. Something like that. No? So it means that if G is truthy, so it contains something, then G is equal to G. If G is false, it doesn't contain anything, then G equal to a default value. So in this case, it's a default value. So instead of if G is null, then G equal to default value, we often see this kind of shortcuts. We use them a lot because we can squeeze into an expression what would be a conditional statement. And so we can reuse this expression value. Okay, so we'll get used to see and or operators in place of if statements sometimes. Just be aware of what we are checking, okay, because in this case the non-defined values would be, 0, empty string, -0, null, undefined, and not a number, okay? But we will see a lot of particular idioms in JavaScript that are used very often and exploit this kind of short-circuit evaluation, and it doesn't convert the value unless it needs to. Okay. This picture can also be useful if you can refer to it if you want to do if you want to ensure that in a given expression a value does have a specific type. So you are not sure the type of your variable, maybe it's a number, maybe it's a string, you want it to be a string, or you want it to be a number. And these are possible syntax ways of expressing that. So if you have a number, you want to convert it to a string, you can call the toString method, you can call the string constructor function, next week for constructor function. You can just take it and concatenate with the empty string, and it will trigger a conversion itself. And if you have a string, you want a number, you can call the number constructor, or you can just use plus. It's a unary plus, it's not an addition, it's the sign of the number. If you apply a plus to a string, it doesn't mean anything, so it will first convert to a number and then do nothing because the plus operator doesn't do anything to the number. So there are different ways of expressing the same conversion. Of course, some of them are more explicit. So number of a string tells me what we are doing, but many times JavaScript programmers are lazy and try to squeeze something less characters. Okay. So that can be, we can refer to this picture if we want to do some specific conversion. Comparison works for primitive types. So I can compare numbers, I can compare strings, booleans. I cannot compare structured data, structured values like arrays or objects, because in this case the operator will only compare the reference and not the value of the object. It is common in many languages, or the equal operator. Like in Java, we have the equal operator that compares the reference and the equals method that will go inside and check the values. Okay, this is the same here. The difference is that or if strings will be compared by value, arrays will be compared by reference, because strings are, you remember the picture, are primitive types and arrays are object types. Okay, so they behave differently. This simple rule of comparing the references is valid only for the equality operators, equal or different or not equal. Unfortunately, the, the less than or more than operators follow a different rule, and instead of comparing references, that doesn't make any sense, basically, comparing the value of two pointers, okay, they will try to convert the objects into strings and then run the comparison. Okay? And it will compare the string version of the two objects, which is not usually the good thing to do, because in some cases, the conversion into a string of an object is a string called object, not the actual values of the object. So basically what I'm saying, don't, okay? Don't expect comparison between objects to work. Always try to do comparison of the values inside the object, but not of the object itself, themselves, because there will be unexpected. Okay, this for operators, nothing nothing special. We will have some friendship with the knowledge management of the operators later on when we do something more sophisticated. And then about control structures, there's nothing really new. They are really copied by the C language. I'm not saying C++ because at that time it wasn't defined yet. So the if condition statement, so with curly braces, we have the else if, we have the else, like in C. We have a switch expression with a case and break, so it's the same syntax as C, with a difference where the expression can be anything, not just a number or a constant or an enumeration. Okay, it can also be a string expression, for example, because strings are primitive types and so they can be compared directly. We have loop statements, so the classical three-block loop in C, so for I equal to 0, I minus then n, I plus plus, for example. Okay, so it works. Normally, the difference is that we can either use an existing variable for the looping control, or in most of the cases, we can define a variable there. So for let e equal to 0, semicolon, I minus 10, and so on. And do while and while are the same copied by C. And plus, we have a special forms of for statements used for iterating over structured objects. And there are two forms. The right one is the good one. For variable of iterable value. For variable of array. For variable of string. Okay? And this will, usually the variable takes the form of a declaration for let A of an array, this is an array, or as a string, and it will iterate the body by assigning to A all the items in the array or all the characters in the string. So instead of writing let A equal to 0 and then console.log array of I, of A in this case, then it's more compact and also clearer. We have a structured value. We will iterate over the values of that object. Remember of, which is not in. In many other languages it's in. In JavaScript is of, because in has a different meaning. In only works if I'm iterating over an object and will iterate over the properties of the object, which is quite an unusual thing to do. Usually, if an object has a property name or property last name or whatever, we pick them by one. We don't iterate, because every property can have different values, so no, it's very unusual, no, that we need to do that. So just remember for of instead of for in. For in will be in very rare corner cases. Unfortunately, in also works in arrays because arrays are also objects, but the problem is that the values of, the property of an array are not just the indexes, but also some other built-in properties. So we'll iterate over also built-in property of the object. I don't want to make it long. Just say, remember to use for of, and let's say forget about for in some way. Using for loops is also a special case in JavaScript because much often we will use a functional method for iterating over a collection of values. So with a for each or with a map operator that we'll study next week, there will be more the normal JavaScript way of doing something on a list or on a collection. Also for exception handling, we have the classical try, catch, and finally statements. We have here some main exceptions that we want to handle. This is for the synchronous behavior of exception. We will see that when we come to asynchronous code, it will be much more complex. So instead, in addition to this try and catch, we'll have other type of objects that will help us to manage the exceptions. They are so-called the promises, but we'll see them much later in the code. So nothing new, as I said, 5 minutes for syntax. And about the data values, let's start from the most apart from numbers, the simplest one are strings. In a JavaScript string, what can I do with a string? A string is an immutable sequence, ordered sequence of Unicode characters. And the fact that these are Unicode characters make it a bit more complex to define what is the actual length of a string, because the number of bytes is not the same as the number of characters. Okay? But unless we are doing strange things at the low level, we shouldn't care, basically. The length of a string is defined as the number of characters, okay, that it contains. Then a character may map to 1, 2, 3, even 4 bytes in Unicode. Apart from that, the strings are, as I said, as immutable. So when you define a string, you cannot change it anymore. So if I define a string as to be hello, oh, I forgot to make a capital H, but I cannot do, okay, S of 0 is the first character, I cannot change it to a capital H. Because you see that it didn't change. So I probably in strict mode, because we are in interactive mode here, in strict mode I would get an error here. We're going to try to modify an object, but you see that the effect doesn't stick. So there's no way of modifying a string like in Java, like in Python. There's no way of modifying a string. You cannot append characters, you can modify characters. The only way of modifying a string is creating a new one and by modifying an existing one. So there are no methods or no operations for modifying the characters of a string. What you can do is just to pick one character, create a new string by concatenation, or query about the length of the string. We still haven't studied objects, but you see that beware that the length of a string is not a method, but it's a property. So it's not the method length with the parentheses that you can call, but it's just dot length as a property, as a constant property as a value property of the object. Okay, so we are usually, if we come from Java, you'll want to put the parentheses, and they will not work because you will be trying to call a number, an integer number. It doesn't work. And then we have some methods for modifying strings. Well, not modifying strings, but for creating modified version of strings. So, okay, the char at usually not interesting because it's the same as indexing a character at a given point. Index of searches a character instead of a string, includes, starts with, end with, no, classical operation. Concatenation is the same as the plus, but these are methods to be applied on a string. Interesting are these ones, these three: split, splice, and substring. But substring is easy. It returns a substring of the string start with a starting point and ending point. So we extract a substring. Split is useful because it splits a string object into an array of strings by separating the strings into substrings. So we split on a comma. You have a string with a list of names separated by comma. You call the split method. You get the single parts of the string itself, okay, from the separator character. Or splice. No, sorry, slice. There are two methods. One is slice and the other is splice, which is not in the slide. Slice is actually the same as the substring because it only extracts a part of the string. Where is that? Okay, sorry, I don't have this in this, but we will find it in the documentation because it's a useful method. Then we have some operations that work with regular expressions if you want to do some sophisticated searches instead of just index of for finding a position of a characters, or includes that finds whether a substring is included in another one. Okay. Trim can be useful also for removing the white space from the beginning and the end of the string itself. Like I was saying, I remember the splice method. It's not in no, sorry, because it's sorry. It works only for arrays. So first we have to convert to array and so. So these are basic operations that we can do with strings, like for example, okay, if we have a string like s, we can say, okay, these are all methods. Okay, what we listed here are all methods, and say, okay, do we have an e in the string? And we tell yes because it's in position 1. Do we have an L? Like actually we have more than one, but the first is in position 2. Do we have a T? No, we don't. It returns -1 and so on. So all of these are methods that can be applied. I want to see the MDN on string. That gives you all the methods here, and sorry, I zoom a bit. All the methods that can be applicable to strings. And for example, we have to uppercase if you want. So for example, with the hello that we forgot to capitalize the first name, we could do it with 2 uppercase, and it will make everything uppercase. We only want to make the first letter uppercase, so let's take the first one. No, 0. And then concatenate the rest. So the rest will be the part of the string from the first characters on. So s dot, I don't know, it's a substring. Let's find it and see that index start, index end. So let's start from the index 1. Substring 1. Substring with an R maybe. And we do that. So nothing special. We just get to know the function that we can work with. And just remember, never modify a string, only apply some transformation to them. And you can save. We have a file here called, that is committed into the weekly repository that we suggest some exercises to do. And let me see the, okay, and suggest, let's start from a list containing some names and try to parse the string and separate on the comma and create for each name an abbreviation. So this is something we can do. Let's forget about the first part of the exercise because it requires us to know how to deal with the arrays of the different names. But just imagine what if I take a name of a person, how can he create, for example, the initials? Just have a simple exercise, some of. So let's call initials .js or .njs. Yeah. So let's start with use strict. Let's define a name as you want. Well, let's take Luigi as example. For example, I can put semicolons or not, as you prefer. So how can we identify the initials of the name? Sorry? Can you? S? Split method. That can be a one way over a space. Okay? So parts of the name, let name dot split. Separator will be a space. You see that the split method works both on a simple string or on a regular expression. Okay, if you want to do split on some more complex stuff. What are you doing here? Name.split. Okay, let's try to, for printing something, we have the print operator is called console.log. Console name. Why don't you like it? Sorry, I don't know this. And log parse. So let's see what it does. We can run this file. Sorry, save first and then run. I don't know why Visual Studio Code doesn't save the file before running, but let's. Okay, so this is what prints. It first prints the name, and the second prints the list with all spaces. What happens if I have more than one space in the name? Or maybe other spaces there? How does split work? Just to be sure. Oh, it creates a list with many empty strings there. So we need to skip those. And so the idea would be for the items of this array that are not empty, just pick the first letter. Okay? So let initials is an empty string to begin with, and then we iterate over the parts for let part of parts. We iterate. If part is not an empty string, remember empty string is falsy, so we don't need to write it explicitly. Initials plus part 0, and just to be safe, to uppercase. Right? So if I save and run, see print, okay, console.log. Sorry, I just finished a course in Python the first semester, so. Yeah, here it is. Of course, this should be something that maybe we want to put it into a function, okay, so that we can reuse it, or a method. When defining the variables, I used let. So my question is, how many of these lets could have been const? Because we'll try to get a habit of using const everywhere except when needed, okay? It's some protection for us. So this one, of course, can be a constant. I'm not changing it. This one also. I create it, I initialize it, and I don't modify it. And these were easy, okay? So if I run this, of course it works like before. There are other two variables. One is this, initials. But actually, I am modifying it. So probably, if I put it as a const, it will not work. If I run and see that I have an assignment to constant value here, constant variable. So this is actually something that needs to be a modifiable variable, because the string is immutable. So every time we need to create a new string and modify the reference. So we are modifying the variable. If it were an array, it would be different, because we could keep the same reference and modify the array object itself. We are doing that on Friday. And this one. This is the index of the iteration. Actually, it turns out that from how the JavaScript manages iteration, the index variable is created at every iteration. So inside an iteration, we don't need, unless we need to modify it for some reason, but it's very ugly to modify the control variable of a loop. You're just seeking trouble. You could do that, but I wouldn't. You have a different instance of variable for every iteration. So inside the single iteration, through the lifetime of that variable, it doesn't need to be modified. So it may seem strange, but it works with const there. So it's quite normal when we have for loops of this kind to declare the loop variable as const. because it's not the same variable that gets modified, but is a new fresh variable at every iteration. Okay? If you add, by comparison, and then I leave it, if you have a classical for example, for I equal to 0, I less than parts.length I++, I could do also this kind of iteration for the same purpose, for iterating over the parts array. In this case, of course, I gets modified here. So it cannot be a const, because it's the same variable and we're modifying it. But in the normal form of iteration, the implicit iteration, they are different variables every time, so we can declare them unconst. So we can prevent any unwanted modification of the index variable. Especially now, if you call them I, j, and k, these indexes, it's very easy to use the same variable for a different purpose inside the loop if it's big. So you can protect yourself like that. Okay, so if it's a classical loop, you must have a modifiable control variable. If it's an implicit loop, you could have a constant loop variable. Okay? Okay, so there's only so much we can do with strings, that you see that you have just methods and concatenation to work with. But on Friday, we'll go forward with the arrays, where we can do something more interesting, and we'll try to implement this, or to solve these two exercises that are listed here. So manipulation of strings, most of that is already done, and manipulation of arrays. Thank you.